Hello, my name is Daniel Presses, and I will be talking about a perceptual model of motion quality for rendering with adaptive refresh rate and resolution. This is a SIGGRAPH paper from 2020 by people at the University of Cambridge, and basically the overview of this paper is that they want to find a way to have on-the-fly motion adaptive rendering algorithms that can support and adjust to the refresh rate of a G-Sync compatible monitor, G-Sync or FreeSync, based on a given rendering budget and observed object motion. A quick summary of their conclusions is that compared to constant refresh rate solutions, motion adaptive rendering, which is an algorithm that they implemented, is an attractive technique for variable refresh rate displays, being able to modify the resolution and the refresh rate based on the image that is being shown in a particular moment. Basically, the key takeaway message from this paper is that people prefer higher resolution images when they are static, and then lower resolution ones when they are moving around, especially at high velocities. This high refresh rate and low resolution leads to a lot less judder, which can be perceived as smoother motion. And the fact that it's moving around so much means that you don't need as crisp of an image, so you can lower the resolution and really drive up the refresh rate. The motivation for this work is that GPU budgets tend to be very limited, and transmission bandwidths mean that real-time rendering often has to compromise on the spatial resolution or the temporal resolution, in other words, the refresh rate. A common practice is to keep either of those constant and dynamically control the other variable, but this strategy is non-optimal when the velocity of the displayed content varies, such as when you have fast-moving objects on the screen. And as display capabilities are exceeding the available rendering and transmission bandwidth, it is very necessary to adaptively control the quality of rendered images through both variables at the same time. So the proposed solution is an algorithm that follows a perceptual visual model that can predict the quality of the motion given the object velocity and predictability of motion. The model considers two major motion artifacts to establish an overall quality score, those being juddery motion, or motion that is not smooth, and blur, especially in orthogonal directions. The paper's contributions were some experiments determining whether this would be a good algorithm to implement. They did one where they showed a bunch of participants the same panoramic image that they could pan back and forth, one using high refresh rate and one using high resolution. And they found that there's a clear preference for lower velocities because higher velocities produce more motion blur, especially at a fixed refresh rate. And content is easier to see at low velocities regardless of the refresh rate. At high refresh rates, when the motion blur is small, the observers are picking slower motion, and at low refresh rates, the velocities are more difficult to differentiate because all the motion looks bad, and differences in quality become smaller. The image content itself does not seem to be a strong factor. More so, the velocity and the predictability of the motions are key factors of the model. The model itself can be seen here in Figure 9. It takes the motion as well as the refresh rate and resolution of different displays and can find a quality of difference between them. As for how to implement this into a real-time solution, given a rendering budget in pixels per second and the horizontal and vertical viewing angles of the monitor, you can determine, based on the resolution and the refresh rate, whether you should have more refresh rate or more resolution, given by this equation here. The paper also validated the applicability of this model in a more complex motion scenario by building a sandbox game in Unity with the proposed motion adaptive resolution and refresh rate rendering algorithm. My personal analysis of the problem is that it's a very good execution, there is very good research and the good use of results from different experiments to implement a possible solution. I definitely think this is a good idea. The people who participated in the last trial tended to prefer more of the motion adaptive resolution algorithm. As for who would want this kind of thing, people who are into PC gaming, and especially those who are into VR, because this kind of smooth motion rendering would very much avoid motion sickness. What will it take for this to become a reality in more modern games and such and make it more popular? A lot more research to validate the claims made in the paper and increase knowledge of the algorithm either through games implementing it themselves, AAA games. Future directions for this research are that there are different types of displays that aren't necessarily variable refresh rates, so low persistence displays, such as the ones on VR headsets. The data needs to be collected for that. We also need to account for ghosting and flicker artifacts, and higher dynamic range monitors, and extending the model to also be content aware are a few major omissions that the author puts in the paper.